Okay, so application of a logarithm. Do you need one to solve either of these? No, I already gave you a question like this. Hopefully most of you solved it. Can't remember who did or didn't. So no, you don't. This might be growth. This might be decay. It depends what these things are in here. Okay, if it's bigger than 1 and you multiply it by itself lots of times, it gets bigger. And if it's less than 1 and you multiply it by itself lots of times, it gets smaller, right? Don't believe me? Try it on your calculator. Alex invests $1,200 at 8%. Compounded semi-annually. What does that mean? Semi-annually. Every 6 months or half a year. That's like a mortgage. That's what they do. Don't ask me why. Just someone made the rules and everyone's got to follow it. So I might have like, I don't know, $4.5 million if this is in for at least 6 years. Hey, huh? Not paying attention. Okay, which formula do you want to use? The money one, yeah. And this is, I mean, it's the same thing, really. It's just a couple of the letters are a little bit differently. So semi-annually means 2 times a year. But as far as letters go, what letter are we talking about here? N. What's N here? 2, right? If it's 10% per year, then that's 0.1. But that means it's going to be 5% every 6 months, which you might think, hey, doesn't that work out to be the same thing? It doesn't, because it compounds. They take that interest at 6 months, they take 5%, and that interest gets lumped onto that principal. And then I compound that again at the end of 6 months. And if I did this daily, every day I would take that 0.0001865 cents, put it on top of my principal, and then compound that again the second day. And then take that interest and compound that the third day. And it makes a huge difference over long periods of time. Okay? So anyway, without getting into the nitty-gritty details, how long before it doubles? Meaning what? I put in 1,200 and I want it to get to 24 at some point in the future. 1 plus I is 8%. I want that as a decimal. 2 times a year. So that's like 4% every 6 months, but it's compounded. T times N. How long? What am I solving for? Yeah, I don't know what T is. Times 2. T2. 2T. Whatever you like. Same thing, right? So, we know how to put that, hopefully, in your graphing calculator and solve for it. Some of you even did trial and error. Some of you got the answer that way. Most of you didn't. Some of you didn't even bother. But we know how to, this is an exponent. You guys know how to make that not an exponent? Like throw it out front here somewhere? Yeah, there's a logarithm rule to do that. Okay, it's called power rule. Up on the wall. But first I want to clean this up a bit. Okay, so that would be 0.04 plus 1. So that's 1.04 to the, let's make it nicer, 2t. Okay? What can I do with 1,200 and 2,400? Okay, yeah. That's the same thing, right? 24 to 12, that doubles. It's also the same thing, 2 to $1. I don't care how much you put in. I just want to know how long it takes to double. Who cares what that is? I want to go from $1 to $2. And the math tells you that's exactly the same thing, right? That's just going to be a 2. There's not enough room here. 2 is 1.04 to the 2t. So how do I solve that for t algebraically? take the log of both sides. I'm going to go up here, okay? Okay, whatever you do to one side, do to the other side. And the reason is, what can I do with that exponent now? This thing I can put down here, okay? Power rule tells me I can do that. So that's 2t times log of 1.04. How would I solve that thing for t? Well, algebraically, what if I divided both sides by log 1.04? Then I got 2t by itself. How do I get rid of that 2? Same thing. Why stop there? Let's get rid of the 2. Divide both sides by 2. T's by itself. Are those logs I can put in my calculator? Yeah, I took log base 10, knowing that I could put that in my calculator. So, do that. Put it in your calculator. T is log of 2 divided by 2 divided by log of 1.04. Look reasonable? What does that mean? What unit is that? Yeah, 8.836 years, okay? Seems reasonable. 8% a year, that's pretty good. It'd take me almost 9 years to double my money. If I started with $1 million, I'd have $2 million in 9 years. Takes money to make money, right? As they say. So it doesn't say how to answer this. So 8.8 years is just fine. Okay? And graphically, we should know how to check that. Scopennium has a half-life of 35 days. I want to use this formula. X to the t over n. So 35 days is which letter? Look back in the notes. It's n, right? That's the half-life or double time or maybe triple time, whatever. Okay, that's n. There's currently 80 kilograms, that's p, that's what I'm starting with. How long does it take until there's only 2? So, half-life. This thing is decay, right? What does it mean, half-life? That means that's the growth factor, and it's less than 1. It's a half, so it's decaying. It's getting smaller. And that tells us that. It starts with 80 and only gets to 2. So I want to go 2 is 80 times 1/2 to the t over 35. Only one variable. Now I know how to solve it. I'm going to take a logarithm. Okay. But first, let's clean this up a bit. Just like we did before. Let's divide both sides by 80. Okay, what's 2 over 80? Make it a decimal if you want. 0.025 is, maybe some people prefer a decimal here. Still says a half to me. To the t over 35. Whatever you do to one side, do to the other side. Take the log of both sides. The reason is now that exponent isn't an exponent, right? Take that guy. I can chuck it down there. So log of 0.025 is t over 35. I just changed the color, didn't I? Yeah, that's really close. times log of 0.5 and solve that thing for t. How do I get rid of that 35? Yeah, multiply by both sides by 35, right? Gone. How do I get rid of the log 0.5? Divide it away. Whatever you do to one side, do to the other side, and that's what t is. Put that in your calculators. I can't remember if I have to put a times there or not. Let me just try it. Log 0.025 divided by log of 0.5. And according to that, it takes that amount of time, which is what I didn't get before. So maybe that doesn't work. 35 times log 0.025 divided by log of 0.5. Oh, I didn't. Oh, well, that's weird. So it timesed it. Okay, so I didn't need to do that, but I made a mistake. All right, that's what I got before. 186 what? Yep. This is in days. Check it. It might be hours. And we should put a unit there because maybe it's in days and it says, what is it in hours, right? So if you didn't answer the question properly, well, I'm going to have to take off marks, right? All right. There's 200 bacteria living in Will's locker, and in 5 days, there's 4,000. Because bacteria in nice, moist, dark places likes to grow, right? This is growth. Could decay if we bleached it. Decay awfully quickly. What's the doubling time? So, I want to use this again. Doubling means x is a 2. Okay? And I got 200 to start with, and then there's 4,000. And again, I want to know the time, or do I? What am I trying to solve for here? Yeah, everyone want to see that? In 5 days, what is the doubling time? Can you make sense of which one's t and n there? Yeah. The doubling time. So that is n, is what I want to solve for here. 2 goes into 40. How many times? Oh, how many times? It's half of 40, 20. Okay, same thing. Take a log of both sides. Can I skip a little step here? Can I just put that straight out there like that? Okay, we're all good? Now how do I solve that thing for n? You probably want to think cross multiply. Right? If I put n up there, that stays there. And then how do I get rid of this log 20? I'm going to put it back where n is, right? Okay? Divided by. And hopefully you can look at that and see if it kind of looks reasonable or not. 1.16 days. Okay. So the doubling time, this is just over a day it doubles, right? So if I start at 200, before the next day there's 400, then there's 800, 1600, 30. Does it seem like it take about 5 days to get to 4,000? Sure. Okay. But you know, feel free to plug that back in. Make sure it works if you got time, right? Before you hand your test in. But you should kind of look at the answer. Sometimes you can kind of figure it out if they make sense or not. Okay, just one more. intensity of light decreases by 3%. Is this growth or decay? It's decay. What's my decay factor? Yeah, okay. So it goes down by 3%. That means each, whatever it is, meter, I have 97% less. 0.97 is less than 1. That's going down. If you like, 1 minus 3%, okay? Which again would be 97%. So what else do I got going on? Every 5 meters, it goes down by that. At the surface, it's 3,000. How far did the light travel? And that's not really a time, is it? That's a distance. So t really shouldn't be t, it should be d. Now it's 1,000. That's even confusing with the wording, now. It sounds like present time. Bottom line is, I started with 3,000. I want to know at what distance is it 1,000. Okay? Yeah. Now makes it sound like a time. So, I don't know. Could be worded better, but maybe we're trying to confuse you. So, this is the factor. 97% every 5 meters, that's n, isn't it? I'm going to cross out t, I'm going to write d, because that seems to make more sense. Let's divide both sides by 3. Okay, so let's just, I don't know, leave it as 1/3, I guess, because I know that's going to be 0.333. Don't round it. Log of 1/3 is d over 5 times the log of 0.97. Okay, so take the log of both sides, throw that down in front, because it's an exponent. Solve that thing for d. All right? And the rest is just calculator. That divided by log of 0.97. What's the unit for the answer? Meters. Meters. Seem reasonable? Yeah, let's pretend it said tenths. Okay. That's all we got today.